Here are the 5.4 notes dividing polynomials. This is page 3, and we've got a couple of examples here. So we can figure out other ways to use long division and synthetic division. Right? So over to the right here, we have the remainder theorem. And the remainder theorem says if we substitute C in, then the result, f of c, is the remainder we would get by dividing f of x by x minus c. Now, keep in mind, that's what we just did. We did that with long division. We also did that with synthetic division. Okay. Here's the important part. Sorry, it's not on one line, f of x equals x minus c times our quotient plus the remainder, f of c is our remainder. This is a big deal. So let's see what that means. I want to find f of 10. So basically, I am dividing by x minus 10. My 10 goes up here in the corner. I have 2x to the 5th minus 3x to the 4th, 1x to the 3rd, minus 2x squared, 1x, and minus 8. I got 2. I'm going to multiply by 10. We get 20. Add straight down. We get 17. Multiply by 10, we get 170. Add straight down, we're at 171. Multiply by 10, 1,710 plus negative 2. Multiply by 10. Add straight down. Multiply by 10. And add straight down. The numbers got kind of big. We can always use direct substitution. And we're going to do that here just so we can compare. So we've got 2 times 10 to the 5th minus 3 times 10 to the 4th plus 10 to the 3rd minus 2 times 10 squared plus 10 minus 8. Exponents come first. 10 to the 5th is a 1 with 5 zeros behind it. We got 3 times 10 to the 4th plus 10 to the 3rd minus 2 times 10 squared. So 200,000 minus 30,000 plus 1,000 minus 200 plus 10 minus 8. So I'm just going to go left to right. Could you combine steps? Yeah. But I want to make sure we don't lose anybody along the way here. That was this. And I'm running out of room. And we get the exact same answer. And as unpleasant as we thought it was doing it using synthetic substitution, right, less pleasant here. Same answer. So we can always use synthetic substitution to find the remainder and use that to evaluate a polynomial at a certain number. So the next one's important because it brings up something we only have done once so far. We want to determine whether 5 is a 0. When I write this out, 1x to the 4th, I've got 0x to the 3rd. I don't want to forget that. Negative 26x to the 2nd, 0x to the 1st, and 25. Add straight down, multiply, add straight down, multiply, add straight down, multiply, add straight down. I have a remainder of 0, which means that when I plug in 5, I get 0 for x. So yes, 5 is 0 of g of x. We're deciding if 3 is a 0, and this would be a good time to pause and just double check that you're okay. And then to find P of 4, this very last one, 4x to the 6th minus 25x to the 5th plus 35x to the 4th plus 17x to the 2nd plus no x's and no constants. I got 4 times 4 is 16, minus 9 minus 36, negative 1. Thirteen times 4 is 52. We get P of 4 equals 208. And that is it for page 3.